Okay, let's continue example 5. You look at this body, the link guided by two blocks at A and B, which move in the free slot. If the velocity of A is 2 meters per second downward, determine the velocity of B at the instant of 45 degrees. So you look at this body, the question actually wants you to focus on the body at point A, B, and you're given a point C. So this one is a tutorial question, so we won't ask you point C, but when it comes to assessment, we might ask you what is C velocity. Okay, so if you look at this link, when A move down, where does B move? How B move? How B move? Point B. We're not asking you about the original. My question is, when you move point A, how point B move? Huh? B move downwards. Again, I refresh my question. When you move point A, how B move? Huh? To the left. What's your answer? To the right. I don't know how you move to the left. Yeah? How B move to the left? And the body, how body move? How the rigid body move? Just now I asked about point. Now I asked about rigid body. Rigid body, you concerned about what? Angular motion. So what is the angular velocity direction? AB direction is what? When you move A down, B move to the right, this body will do anti-clockwise. Velocity and acceleration same. Okay, so this one you move down, this one will rotate like that. Okay, so you need to determine velocity at B. Okay, there are two ways. All right, so you draw your kinematic diagram. A, you know, move toward B to the right, right? Then you move link counterclockwise. Okay, you do right hand rules. Right hand rules. Where does the angular velocity directed? You're directed outwards because you move anti-clockwise. Okay. So you draw your free body diagram, or more exactly is kinematic diagram. So in your incoming assessment, you will see the question asks you to draw free body diagram. It also means that it expects you to draw kinematic diagram. Okay, although there's no force inside there, but it's a velocity and angular velocity. Okay, so we expect you to turn the scenario into kinematic diagram. So here, your VA move down, so you draw A move down. VB move to the right, so you draw move to the right. And you anticipate or you expect, you project or you predict rotation is anti-clockwise for this body. Right. And then distance between A and B, you write, you always focus on one point. You can focus on point B also, but we always focus on one of the point. In this example, we focus on point A. So we write R B stroke A means we stand at point A, we look at B, so we write R B stroke A. Okay. So we do vector analysis, then scalar analysis. Both reach the same answer. So vector analysis means we convert what we see here into into ijk. Do you see 3 vector here? 4 vector. 1, 2, 3, 4. Right? So we'll use VB equal to VA plus VB stroke A. We convert VB stroke A equal omega cross R. Okay. So what is VB? When you write in IJK, VB equal to positive I, what? Positive VBI, right? What about A? A is minus 2J. Let's go down. Then omega. Omega come out or become positive K. Okay. Cross, you copy. R cross B. RB slash A means this distance. This is a vector. Convert this vector into x direction, y direction. So how do you find x direction? Is what? Sine 45. This one cos 45. Nico, improve on your trigonometry. You're quite weak in this one, especially your test one. So VB, so you continue with the rest of the calculation. Any question on this one? Okay, so you cross omega from y positive. We use what rules? Ryan rules. Show to your friend how to get K up going outward.
Positive. Okay, sorry, this way. ST positive or negative. It's going this way.
You understand right hand rules or not? What mean by right hand rules? What mean by right hand rules? Your finger is what? You put your right hand on the object. You curve in. What your finger tell you? What your finger tell you? Go in or go up? Go up means what? You do the cross. If you don't understand how K cross I get J, go back to your calculus textbook. Okay. You come to engineering dynamics already, means you are expert in maths already. Okay. So you do the mathematics. You have I, of course, this one is should not be small, typo error. I should be big. So you group I with I, J with J. What is your component in J? On the left side. You group I with I, J with J. I, you have VB equal 0.2 cos 45. What about J? Huh? Yeah, you do grouping. I you get VB equal 0.2 omega cos 45. Right? What about J? Got J meh? Where J? Do you see J? On the left hand side. So what you get? 0 equal minus 2 plus 0.2 omega sine 45. You got two equations. Solve simultaneous equation. Okay. You will get omega. This one you can get omega. Substitute omega back here. You get VB. Omega anticlockwise. Why anticlockwise? Why this direction? Yeah. Because A move down, B move that way, rigid body rotate that way. VB to right. Focus on B. Same. Okay. You do scalar analysis, same. But the free body diagram will be different. This is vector diagram. If you do scalar, you only see this one. Scalar means you look at the diagram, you look at what point B will behave. Your VB will go this way. Okay. So same, VB equal to VA plus VB stroke A. Why VB 45 go this way? VB stroke A. Okay, VB stroke A means what? You observing from what point? VB stroke A. You stand here. So when you stand here, you're actually seeing B is moving this way and not this way. Okay. So you put in, you do the scalar means you don't use cross products. You straight away V equal to omega R, V equal to omega R, but bottom of each one, you give it direction. VB to the right, VA go down, VB stroke A 45. Okay. So the relationship between omega and V always, I mean the R, omega and VB always 90 degree. Okay. So that's why I get a 45 there. Then you do the same as your X and Y component. You do for horizontal. So horizontal VB, this one you don't have. You break this one into X and Y direction. So same omega 0.2, what is your X direction? Omega 0.2 sine of cos 45, get the X direction. Do it for the Y. Y, what is the value for VB? 0, because no go up. Then this one become -2, then this one become positive omega 0.2 sine 45. Okay, so you have this one. Same. This second equation help you to solve omega. Substitute back here, you get VB. So there are two methods to solve. Okay. So example 6, same. Example 6, same. So a roller without slipping. Without slipping means there's no loss of energy, there's no loss of velocity when there's a contact, two body contact. So cylinder roll without slip on the surface of conveyor belt is moving at 0.6. So this is on the is on the conveyor. This conveyor move in 0.6 meter per second. You are given a reference plane x and y, means positive to the x, going up is y. You are given omega with its angular velocity 15 radian per second. You are given point O and point A, radius is 0.5. So when V conveyor move to the right, the motion of the disc will be in this direction, right? So this one will rotate in this one. Okay, so you can see that conveyor move this way, but omega move this way. Actually, is if this one do not give you a normal one, will be following the conveyor, right? But this question, the cylinder actually moving opposite of the conveyor. Can you see it? Can I? All right. So determine the velocity of point A. Cylinder have clockwise angular velocity at that instant. So you're looking at what body? You're looking at conveyor or this? Which one is a rigid body? What is your main target? You're looking at conveyor or looking at the disc or cylinder? Cylinder, huh? The question keep repeating the word cylinder and point A. So where is point A? It's on the cylinder. So you focus on cylinder. So what is the velocity at point B? You look at the diagram. The word no slipping. You know what is meaning zero? You know? Just now you say VB is zero. What does it mean? Then what is omega 15 radian per second tell you? This body is moving. So cannot be zero. Zero means do not move. It do not tell you starting from rest. There's no statement saying starting from rest. Okay. So you draw the disc. VB will follow the conveyor direction. Because conveyor 0.6 this direction. So this point will copy velocity of this one. Then you refer to A from B because you're focusing on point A, velocity of A. So you have B. So you draw vector B pointing to A because you want to find A. So you stand at B. Why you choose B and not A? Because you have more information at point B. You have a certain value of 0.6 for point B. You don't have any value for point A. You don't know what is the velocity. But for B, you confirm you know VB to X direction. That's why we choose B rather than A. The previous example, 4, 5, 6, we always choose A. But example 6, we choose B because, again, B have more information to process. So we choose B pointing to A, we write R, A / B. Then velocity A. Why this direction and not this direction? Because velocity in the rigid body always 90 degree with the radius, with the relative radius here. Always 90 degree. So use your ruler, put here, draw arrow. Then you refer to flat surface. You draw a horizontal line and put theta there. Okay. Then you start to solve using the equation that you know. You have VB, you have R, you have VA, you have omega. So velocity equation, VA equal to VB plus VA stroke B. Okay. So what is VA? By using vector analysis, VA is what? How you break VA into vector? You know what is vector, right? It's IJK. You have vector VA now. You have angle. So how you break this into IJK? Cos theta I. Okay. J lah. Y is go up ma. We give you the Y already. If this one is changed to Z, then become K. Right? Then VB. Why you include VB and 0.6 together? What's the answer? VB for VB in scalar? 0.6i. Omega? Positive, negative? What rules you use? Okay. What your finger tell you? What your thumb tell you? Why negative? Pointing in. It's pointing into the screen. So negative K. RAB? 0.1 is what? Radius. Is R stroke B is radius? Okay, so what is RAB? How do you write? How do you turn the vector of R? Just now you know how to do for VA. Do the same for RB stroke A. How? This one? Negative what? Okay. What is your theta in this case? You know the theta actually. There is information in the. What is the theta? It's solving triangular in the circle. Okay. You know A and B, both of them at what degree? Huh? 545? 545? 545? Anything right on the screen here, 45. But how come you arrive at 45? about how you prove. We are not talking about set of how you feel. We talk about mathematics. What is the relationship between A and B in a circle? If you look at diagram, what is the angle? What is A and B angle over here? What is this angle? 90. This is what? You learn about triangular, right? You have the same side. What do you get here? So here also 45. So what is your RAB in x direction? .15. Okay, correct. Sine or cos? Then your y? Okay. You have all this, right? So okay. So here your R you write in 0.5 I and 0.5 G. There's no cos. There's no cos. Here to here is R. Here to here is R. There's no cos there. So here is negative R, positive R. What is your R? What is the length of this one? Here to here. You break this one into like this one. This one to here. So what is the length of this one? Same as R. So what is your R? 0.5. Okay. 0.15. Yeah. 0.15. What is cos 45? What is cos 45? Zero point 7170, right? I think it's a typo error there. It's a typo error. Okay. Let me see. 0.5. One five. You find do you get 0.5? I don't know. Zero 0.25. Wait, I think it's something wrong with my calculation. Zero 0.5. You take 15 times 0.15, do you get 2.25? Okay, then there's a typo error here. Okay, there's a typo error here, not 5, not 0.5, it's 0.15. Okay, okay, then it solves the okay. So you group them together. So I, you have 0.6i plus 2.25i. So you get your VA, X direction. You do the same for J. J only have 1. VAY equal to 2.25. So you get your VAY. So you have X and Y, you need to find the resultant. Square this one plus square this one, square root. Okay. Then you get VA. Direction, you should able to find. It's a tangent. Then you get 38.3, which is here. Okay. Scalar, how you do? Again, scalar, when you do scalar, it's a bit different from for the free body diagram. So scalar, now you change same lah. Now you have a 45, 45 like that. Okay. Again, V and R and omega, they are 90 degree. Here, they are 90 degree. Okay. So, and why 90 degree? Because A is in the circular motion, collinear motion. So you write VA equal to VB plus VA stroke B. VA, you change VA into XY direction. VB only have one direction, which is in X direction, positive, because it's positive to the right. VA stroke B, VA stroke B in scalar means straight away you use this equation. This is scalar, V equal to omega R. If it's a cross means vector analysis. So V change to omega R stroke B. You draw the direction below the equation. Then you group based on X direction and Y direction. Okay, so same, huh? So need to be careful is the unit. Okay, omega is in radian per second. Okay, then you get the same answer. Okay, get the same answer for VA and VB, huh? Okay. Next, this is one set of calculation on rigid body. Now we show you another set of calculation. I prefer this one actually. This is also my favorite. So we will look at one location is called instantaneous center of zero velocity, meaning from the diagram itself, we build another reference point to stand on that point and then we see what happened to the body. So how do we draw the IC direction? So this IC is a point from A. Like for example, this is a rigid body. So this A, you know how if this rotate with omega, you know that this one is in this direction. So A will be in the collinear motion. So when you have collinear motion, your VA will be moving in tangent direction of this blue line, right? So you know how to draw VA and R, right? They always 90 degree. So what you do, you put a ruler, you use your transparent ruler, put here, and then draw a line 90 degree. You will get a position of your IC. Okay, you need two, right? So on the rigid body, always focus on 2 points. So you will draw 2 points to get the position of IC. Okay, so the rest I will just keep lah. Important thing is how to draw the IC point. IC means at that point you have zero velocity. That means you stand there and look at the body. Okay. The rest you read lah. And again, how we find the distance from the IC point. So you stand at IC. So means you look at that point. Mathematically, how you write? R of that point slash IC. Again, recall what is V in omega and R term. V equal to omega R. You move the omega to left, right hand side. Okay. The rest you read. So important is you always use ruler to draw the IC point. For example, this rigid body. Rotate clockwise. Rotate clockwise, where is your Z? Your Z? Come in or go in? How come go in? You put your finger like that, then you refer lah. Your thumb go up, so your direction actually come out. Okay, so you know that this body, the A and B always same distance, like your eyes and your mouth, right? So how you do, when this one rotate, you know that A and B will rotate in a circular motion. So when circular motion, A will be in a circular motion, and you can draw the vector diagram, right? Not vector, velocity direction, always tangent to the curve. When you draw tangent to the curve, you mark point A, use your ruler, the transparent ruler, put there, use the side to help you to draw the line. Go to point B. Point B also moving in this direction, but you know this is also collinear motion. VB 90 degree tangent. Again, use your ruler, put on the velocity, and then your edge of your ruler, you point there, then you draw a line. These two will meet at your IC point. This IC point will help you to calculate your omega value. Okay, so this one, again, how to find VC? V equal to omega R. You move your omega to right hand side. You get R. Okay, so same. Repeat the same process like just now. If you have body, let's say you have this body, rotate. This one is anti-clockwise. So it's going in. So if this one in this direction, you point A will rotate this way, right? Velocity this direction, right? Put your ruler like this, then draw a line. Okay, B, same, rotate this direction, VB will this direction. Use a ruler, put there, draw a line. It will intersect at the same point. How you get the exact point? By measuring the vector length. The arrow point to arrow, you get intersection point. Okay. The rest, the principle still same. You're still using back V equal to omega R. Then find what is R, A from IC point. Or is it B from IC point? Okay. Right. So in this case, if you're given omega, you can calculate the distance of R from IC. Okay. Then the total distance is D lah, if it's on the same body and if as two edge of the body. Okay. So let's look at this example 7. Example 7 is illustration or guide you how to draw the IC location. So if you look at, we have two cases here. So how to determine the location of IC for A and B? Let's look at A. A diagram, it gives you two link with its AB and BC. When the omega moving in the clockwise direction, clockwise, go in. Okay. So B will move in a circular motion. C will move in a linear motion. Okay. Then again, focus on the question. The question asks you to focus on BC. So how you draw? So again, do you know how to draw velocity vector for B? It's 90 degree, right? Like this one. Okay. What is the C vector? Going right. Now you know the trick. Draw the arm or link. Put in B, C here. Draw the motion of B, draw the motion of C. Put in the velocity. Velocity go here. Right? C go there. Of course, there's a angle there lah, from a horizontal. C will go there. So again, recall how you draw the IC line. Put your ruler here. Draw a line. Put your ruler here. Go to the end of the vector. Draw. Okay. This is how you draw the IC line. Your IC point is here. How to calculate the radius or the distance from distance of RB IC? How we calculate? R equal. Okay, you use this equation. V equal to omega R. You want to find R, move your omega to left hand side. Same in here. Here, you R C slash IC equal VC divided by omega. So when you will be seeing this arm, when this move now, this arm will move clockwise or anti-clockwise. When this one moves down, right? It will be clockwise or anti-clockwise. How come clockwise? I'm asking about the BC body. Not point, not point. So it's like that, right? Okay. This one move down, it's like that, right? So it's a anti-clockwise, so go in. Okay. So your omega is this way, and if you stand at IC, you're actually seeing the body swing like that. No, yeah, clockwise is pointing outside. So if you stand at IC, you look at BC. Actually it is swinging. Okay, what is important on example 7 is to try to identify how you draw IC location. First, you look at the motion. Does it move straight or circular? circular motion. Circular motion always tangent, velocity always tangent. Okay, let's look at second case, link CB. So link CB, our system consists of DC, CB, and BA. So when D move clockwise, what happened to the body of CB body? This one moved down, right? This body will move down, and C will also move down, B will also move down, right? Okay, A do not move lah. A does rotate. Okay. So how do you do? You draw the focus body. In this case, CB. Mark the point. Where is the velocity pointing for C? Point up or point down? Or point left or point right? Go down because omega DC go this way. Velocity go down. What is B? B velocity go down as well. Okay. So when you draw ruler, what do you expect the IC? Where? Where's IC? Okay, look at point C first. Where's the velocity? How you draw IC line? How you draw IC line again? Use your transparent ruler. Then you put here. Then you draw where? Draw here. Right? Okay. Then go to B. B go down, right? Put your ruler here. Draw where? Draw left. There's a two line meet. There's a two line intersect. Huh? No, huh? So the calculation is infinity. So we go down, and omega BC will rotate clockwise. I mean, we assume now, we assume omega CB will be clockwise. But from calculation, it tells us, you know why RC this way, right? Means from IC point to, I mean, C from IC point, but you point angle there, the direction is there. Okay, so RC is from infinity, RB stroke IC also infinity. How to calculate omega? V divided by R. What you get? What do you get? Huh? Huh? Infinity. How you get infinity? This is R. How you get the omega? So I give you chance to think again. How to calculate omega? V divided by R. What is R? What you get? Huh? What you get? You get infinity or you get zero? Okay, this is a common sense, man. You learn in your, you first heard about infinities in your secondary school. You divide something with infinity, what you get? Yeah, it's a simple logic. You learn in your secondary school. think. This is not something complex. How you get omega? V equal to omega R. Omega equal to, what is your R now? What do you get? You get infinity. What mean by infinity? No what? Okay, another explanation on no limit. What does it mean? Huh? What mean by never ending? You divide something with never ending, what do you get? Okay, you draw graph, right? Infinity, right? This is 1, 2, 3, 4, 5. 9, 9, 9, 9, 9, 9, 9. Infinity. You take something divided by, what do you get? Infinity means very large number. What do you get? Come on, this is standard 1 question. 0. My God. Okay. So omega, you divide by infinity, you get 0. What I mean by 0? No angular velocity. Makes sense, right? If you stand here from IC point, you look at point C and point B, what do you see? The object just shift like this. It do not rotate. It do not rotate in a funny way. Just it's just translation. This is angular. Same. Right. So yeah. Okay, go home and think. So of course, it's from a very long distance. Okay. Example, you have class, right? Okay. One more. One more. You have a system like that, 1 arm, 2 arm, and D. We have an angle, 90 degree. Block D moves speed 3 meter per second. Determine angular velocity link BD and AB at instant show. Okay. I would like to use the IC method. I personally like. There's other method which is you cover previously, right? So you focus on BD first. What is the velocity vector you have? D pointing to the right. Point B, when D move, point B will do what? This one will move like that, right? So B will move in what motion? Linear or collinear? Collinear motion. Collinear motion, how to draw vector for B? Tangent to the curve, right? Okay. So coincident that this is 90 degree. Coincident, the vector B is along this axis. If this is not 90, then you will see there's a different location of your B. The angle of your vector will not same. Okay. So very easy. Here, you should understand why VB that pointing that, because of AB rotation. So VB go direct 90 degree here. So coincident in this case. So VB here, VD here. Again, I would like to move this one here. Use your ruler. Put here, draw. Put your ruler here, draw. You got your IC, you can find omega. Yeah, so I do like this. You already know the concept already. I just put in the value. Arrow always from IC point to point B. Here with this, same. You know how to find omega already, right? V equal to omega R. Put this one here. You have this one, you have this one. Right? You have this one, you have R. You're able to find omega of that body. Same with this one. If you use this one also, you'll find the same omega. Okay, so you find all these things, right? So your R you can find is 45 is a right angle triangular. So RB you can find is tan 45. Right? BC also same cos 45. So from there, you find your omega of BD. So you take point D. So omega is so and so. Okay. So it's safe to use the D point rather than B because B linked to another body. So you use D safer. Right? So velocity B same. Result B is V equal to omega R. You use this VD and the R is this one. Okay, you find VB. So 45 degree go down, and then you move to the AB, same. You draw the body. VB, you know, is this direction, right? Why no velocity at A? It's fixed pin. So don't suka, don't be so clever, you go and draw V. No V, eh? So same. So you have that one, and you know that this fixed, this rotate this way, you have an omega, this one. What is omega? V equal to omega R. So again, take this one divided by R, you get omega. So don't be confused with the question. Always think how this thing move, what equation I have. The equation is actually very simple one. You only look at V equal to omega. And then try to use a ruler, draw the IC, and you find the answer. Okay? Nothing complex here. We will continue 5.7 next lecture.